everyone, I'm Marius from Inventas in Norway, and today I will be showing an open source regression tool called HDLRegression that makes FPGA testing faster and easier. I will start out with some words about Inventas. Inventas is Norway's largest independent design house. There are about 170 designers and engineers, and we do a lot of embedded and FPGA projects for medtech, space, and subsea. And we develop UVVM and HDL regression and have a strong interest in proper verification and methodology. So these are the topics I will be covering today. We begin by looking at some of the key verification challenges. Then we have a look at what regression testing is, and followed by how HDL regression can help us with this. So these are the numbers from the 2024 Wilson Research Group FPGA Functional Verification Trend Report. In this report, 87% of the FPGA projects reported to have at least one serious bug in the field. And 67% of the projects reported that the planned schedule was missed. So these are very high numbers. It is also reported that verification can be half of the total effort, and debugging is the biggest time sink. So there is no doubt that proper verification needs more attention. So why do we have these kind of problems? Well, the report states that bugs are found late because teams do minimal testing before going to the lab. Also, the designs get bigger and bigger and more complex. Many teams use ad hoc simulation scripts, which needs to be manually maintained, which again takes time and are sometimes even forgotten. We also see in the report that debug is unpredictable, and one failing test can cost days to fix. And when we do one small fix in part of the design, something else breaks because of the changes we did. Before we look at regression testing in detail, let's put it in context. FPGA projects benefit from a range of testing approaches. We have unit testing, integration tests, system testing, formal verification, black box testing, and so on. And regression testing sits besides this, ensuring changes don't break previously working behavior. Now, what is regression testing then? Well, regression testing simply means that we rerun our old functional and non-functional tests after every change we do. And if an old test, which used to work before, now fails, we have a regression. A regression flow should be automated and repeatable. And because FPGA simulations can take a lot of time, a good testing strategy is important. So now that we know what regression testing is, why do we need it? Regression testing gives us confidence. Every run proves that the design still behaves as before. We also get an early fault detection. The tests run right after each change, so we catch new bugs the same day and not weeks later when we have forgotten what we did. It is very easy to automate. We can plug a script into the continuous integration pipeline and we're good to go. And we can have fast fixes. Because the bug is found quickly, it is fresh in our heads and we can repair the issue right away. Now, it's important to know the difference of retesting and regression testing. Retesting is when we rerun a test case after fixing a specific bug or implementing a new feature. And the process is usually manual and confirms that we have fixed the defect or implemented the new functionality. Regression testing, on the other hand, is broader. It checks that other parts of the design still works after changes by running a broader set of test cases. And regression testing is often automated and done continuously. But both testing approaches are important, but they serve different purposes. FPGA projects are especially sensitive to regressions. Any change to code, constraints, or tooling can lead to problems. And simulations are long, test benches are complex, and changes ripple. So that is why also FPGA projects need good regression strategies. Now, there are some qualifications that a test case needs to fulfill for it to be used in a regression system. A good regression test should have a defined purpose. It should be deterministic, self-checking, consistently passing, and have clean dependencies. And when a test case passes all of these requirements, it is safe to include in a regression system. One should have an effective strategy for the regression testing. Do not run every test every time. Use different test scopes. Smoke tests or key functionality can be run on every commit. And full regressions can be run nightly or before milestones. And of course, the process should be automated. So now that we have a good strategy, we need to know how to use it. Daily regression should focus on fast, stable, and critical functionality, like resets, FSMs, registers, and protocols, while milestones or nightly runs can include full system tests, corner cases, and long simulations. There are some potential pitfalls that we need to be aware of. Without structure and ownership, regression testing can fail. Flaky tests or outdated scripts reduce trust, and if people stop paying attention to test results, bugs will slip through. So we need to keep the suite clean and assign clear responsibilities. There are several benefits of automating our testing. Automation gives us faster and more reliable results than manual testing. It increases consistency and reduces time and cost, and it also enables frequent testing and better reuse. Regression test automation with continuous integration also have several advantages. The test run gets automated and is run on every push to the server, so we will see errors right away. We can configure the runs so only the tests that matter are executed on every push, meaning we can get results quickly. We then can run small quick set on each push and a full set at night or at milestones. We will have logs saved so we can see exactly when a bug got introduced. And it also promotes small and frequent pushes instead of large commits at the end of the day. Now, before introducing HDLRegression, let's have a quick look at what a good regression tool should provide. It should, of course, support your simulators and be easy to adopt. It has to scale with your project and integrate with continuous integration systems. It should also support debugging, different frameworks, and be scriptable. Now, moving on with HDLRegression. HDLRegression is a free and open source regression runner. It's written in Python. And the focus is simplicity. So we want to focus on writing good test cases and not use lots of time on scripts. And the startup is very easy. One only need to add a common pragma in the test bench. And the tool is framework independent, meaning you can use UVVM, OSVVM, VUnit, or any other in-house testing framework. And it supports several simulators, and more are coming. Now, a test case is typically a sequence controlled by a test sequencer. It may test one or several functions or requirements in a logical flow. And HDL regression needs a pragma to recognize a test bench, and there are no naming rules or other requirements. The pragma is a short comment which needs to be added to the test bench entity, here shown at the top of the code. HDL regression will now find the test bench entity and figure out the rest of the test suite. So when HDL regression finds this test bench pragma, it will start to build the test suite structure. And there are several parameters that creates a test case. First, we have the test bench entity. This can have one or more architectures, and each will be one test case. Next, we have generic values on the entity, and any combination of these and with the architectures will again define test cases. And finally, we have the option of having test cases inside a single test bench sequencer. And these test cases are usually small unit tests. In addition to adding a pragma comment, we need to write a regression script in Python. There are templates available in HDLRegression, but it should be straightforward. In the Python script, we need to import HDLRegression and add the design and test bench files, and then call start. I recommend that you use wildcards when adding files, as shown here. This way, we do not need to manually add or remove files later. And as you can see here, there are not many lines of code needed, and the same script can be used for running RTL and gate level simulations. And the same script is also used for running locally on a computer and on a continuous integration server, which is great for local debugging and testing. And because we are writing in Python, we have the full Python language available to configure our tests. Now, the default mode when we run our HDLRegression Python script is that the tool will run all test cases that have not been run on and those who failed the last time we ran. But it is also possible to do retesting by running only the one test case or a set of test cases. We can get a list of all of the test cases in the test suite and use the test case ID number or test case name to run a selection. It is also possible to use wildcards when selecting test case names. So during debug, one can run the failing test case alone or the test case one is working on, and not the whole test suite. HDLRegression has something called test groups, and we can use test groups to define daily and nightly regressions. For small designs, one probably would run a full regression every time, but for large projects, we should have a good test strategy and use test groups. So we can define test groups for short daily sanity tests and test groups for long tests that should only be nightly regressions or on milestones. We can use the command line interface to get a list of all of the test groups and all of the test cases in each test group. And we can use the command line argument to select which test group to run. And if we do not select a test group, the normal regression mode will be used. When debugging, retesting, or working on a feature, we want to get instant feedback. So running the test suite in regression mode means that only test cases affected by changes we make, maybe in a package, a test bench component, or a sequencer, are run. We get a pass or fail information in the terminal and does not have to inspect any wave diagrams. The script also gives an exit code indicating success or failure. HDLRegression is well suited for small and large projects, and its simplicity is also its strength. The test suite is controlled by the tool, meaning you do not have to remember to make updates when adding new files, and all is simulated. Using wildcards with the add files method in the regression script ensures all files are included. Often you do not have to update the script during the development of the project. And when the number of files and test cases expand, it is also possible to perform tasks in parallel. So we can do pre-processing of files and libraries in parallel. And if you have several simulation licenses, you can also do simulation in parallel. Here's an example of a regression run where all test cases passed in the previous run and no changes have been made. HDLRegression tells us that there is no test cases that need to be run, and we have saved unnecessary simulation time. It also tells us that we can use the full regression command line argument to force a full rerun. Then we do an update of a file. HDLRegression detects this change and figures out what needs to be recompiled and tested, backs up our previous runs, and start compilation and simulation. We want to work in the terminal, but sometimes we need to look at a waveform and inspect signals and timing. HDLRegression lets you work on your design and run a test case from inside the simulator graphical user interface. It gives us a menu with commands that we can use to work interactively in the graphical user interface, such as recompiling and running our simulations. And HDLRegression also works well in continuous integration setups. You can run the same Python script locally or in a continuous integration pipeline. It gives a green or red badge based on the result and stores logs and coverage for later review. And this makes it easy to track regressions and prove test completeness over time. The tool comes with a full PDF manual, including install steps, example scripts, and full API documentation. You can configure generics, select coverage options, and control the simulation flow directly from inside a regression script. So, wrapping things up. Regression improves the verification flow, especially when it runs on every push. And HDLRegression makes that very easy. There's one pragma, one small script, and works with any framework and gives fast feedback. And it is open source and free on GitHub. So thank you for listening.
Any questions? Yes, we've got a question here.
Yeah, maybe an obvious question. What would it take to extend it to UVM?
What question?
Can you repeat?
Sure. Hi. So thank you for the presentation. So maybe an obvious question. What would it take to extend this to UVM? Or is it already supported?
Yeah, not much. I need to make some new drivers for UVM test benches.
Thank you. Any more questions? Okay, thank you very much, Marius.
Yeah, no problem.
Thank you.